First created in the early 1950s, robots are considered the future of the new generation. With innovations in the development and functioning of robots, there is a robot that has made unbelievable improvements to its robotic simulation and learned in just 32 hours. What is this Nvidia's AI robot and how did it learn in just 32 hours? Let's find out in this video. But before we go any further, make sure to leave a thumbs up and subscribe to our channel so you never miss our daily dose of informational, inspiring, and educational videos. Now let's get started. For the last few years, many researchers have been working to make robots walk, operate, and perform various tasks assigned by humans. It has become increasingly difficult for robotic systems to emulate the fine motor skills that human hands are naturally capable of and most of the time take for granted. However, scientists have recently offered a method to advance these capabilities, which is deep reinforcement learning techniques that can train a neural network to learn by trial and error how to control the joints of a robot. Founded in 1993, an American multinational software company, Nvidia believes that it has developed a high-performance physics simulation environment for reinforcement learning that can effectively help robots to emulate human motor skills. One of the famous launches of Nvidia, Omniverse-powered Nvidia Isaac Gym, is a synthetic data generation tool and scalable robotics simulation application that powers physically accurate virtual environments. Not only this, but it also helps with a faster and better way to develop, test, and manage AI-based robots. According to the developers, photorealistic and physically accurate environments created by Nvidia Isaac Gym aim at developing and testing every aspect of robot operations. According to the company, Isaac Gym is that magical platform that enables robots to be trained inside a simulated universe that can run more than 10,000 times faster than the real world. Talking about Nvidia Corporation, it is a platform that designs application programming interfaces for data science, graphics processing units, and high-performance computing, as well as system-on-a-chip units for the mobile computing and automotive markets. Due to its unremarkable work, this company is now known as a global leader in AI software and hardware. In robotics, Nvidia Research is using AI to enable development that solves real-world problems in industries such as manufacturing, logistics, healthcare, and many more. The new Nvidia AI Robotics Research Lab focuses on different areas including physics-based simulation, robot manipulation, and robot perception, with its goal being to develop the next generation of robots that have the ability to manipulate the physical world and work alongside humans robustly. For robots to work in the human world, the ability to dexterously interact with tools and the environment around them is critical. Without this ability, they would be useful only in specialized domains such as warehouses or factories. Teaching robots with legs has been easier than teaching them with their hands and how to do movement, because a hand with fingers has more joints that must move in specific coordinated ways to complete a given task. However, with deep reinforcement learning, a robot can learn from trial and error to complete the assigned task. Unfortunately, this technique may require a lot of samples to learn from, making it almost impossible to apply it directly to real robots and make it work. Researchers from Nvidia companies solved the problem and convened the D-Extreme project to use Isaac Gym to help teach a robotic hand how to manipulate a cue to match a provided target position in orientation or pose. The neural network brain learned to do this entirely in the Isaac Gym simulation environment before the project advanced to physically teaching the robotic hand in the real world. In robotics, the use of deep learning is more general than any other learning algorithm. In this field, deep networks can think and abstract at a high level, making this type of reinforcement learning an ideal choice for robots in an unregulated environment. Both for training and inference, deep learning relies on GPU acceleration. Nvidia delivers GPU acceleration to data centers, laptops, the world's fastest supercomputers, and desktops. Nvidia GPU Deep Learning is now available on services including Google, IBM, Amazon, Microsoft, and many others. With AI and deep learning, the world of computing is developing and computers are now learning to write their software more accurately. The robotic hand that Nvidia used is an Allegro hand, which was centrally chosen for its affordability and huge adaptivity. Robotic hands are complex and difficult to control. When the human hand consists of 27 different bones, 34 muscles, and 27 joints, all working together and helping to perform daily tasks, the Allegro hand has 4 fingers instead of 5 and has no moving wrist. Incorporating natural human skeletal structure and function into robotics is more challenging than developing robots. The company made these attributes a priority because, like many other researchers, it also wants to be able to replicate the efforts of the D-Extreme project affordably. Robots are trained with their neural networks on about 100 years of experience, which was achieved in about 50 hours by using Nvidia Tesla V100 GPUs and the CUDA accelerated TensorFlow deep learning framework. The developers said that the Dactyl system is trained entirely in simulation and adapting to the real world, transferring its knowledge to reality, using techniques we have been working on for the past year. The deep learning system is taught to learn human grasps, such as the prismatic, tripod, and tip inch, as well as behaviors and actions, such as finger gating, finger pivoting, sliding, the controlled use of gravity, multi-finger coordination, and coordinated application of translational and torsional forces. For reinforcement learning, the D-Extreme project is trained using Isaac Gym, which provides an end-to-end GPU-accelerated simulation environment. During the training of the Deep Learning Control Policy Network, NVIDIA Physics simulates the world on the GPU, and the results stay in GPU memory. As a result, training can be done on a single Omniverse OVS server. On this system, training a good policy takes only about 32 hours, equivalent to 42 years of a single robot's experience in the real world, which is the specialty of NVIDIA. Isaac Gym can be used to train the model, and training time and cost can be reduced. The perception system helps the robot to know the current orientation and position of the cube that it's holding. This network uses about 5 million frames of synthetic data generated using Omniverse Replicator and no real images to train the robot's neural network. In the real world, a network learns how to perform tasks under challenging circumstances. Using a technique called domain randomization can help change camera and lighting positions, with data augmentation to apply random crops, rotation, and backgrounds, and give the network more robust capabilities. The D-Extreme project pose estimation system is reliable and can recognize accurate poses even when the object is partly occluded from view or when the image has significant motion blur. One of the reasons to use simulations is that in the real world, training robots directly is taken over by various challenges. For example, robot hardware is susceptible to breaking after excessive usage. During the experiments, the hand can be repaired after prolonged usage, for example, replacing the ribbon cables, tightening the loose screws, and resting the hand to cool down after running 10 to 15 trials. Simulations enabled many of these issues by training on a robot and providing the large diversity of data needed to learn challenging tasks. The most significant challenge that is faced in training a robot is bridging the gap between the simulations and the real world. For this, D-Extreme uses domain randomization of the physics properties set in a simulator, friction levels, changing object masses, and other attributes at scale across over 100,000 simulated environments at one time. NVIDIA wasn't only competing in this field. Another famous company, OpenAI, has also made progress. NVIDIA noted that OpenAI researchers have been able to accomplish something similar, but that project required a supercomputing cluster of hundreds of computers for training purposes, as well as a far more sophisticated and expensive robot hand, and a cube tricked out with precise motion control sensors. Researchers at OpenAI announced that they trained a deep learning system that can grasp and manipulate real-world objects with amazing dexterity. They also stated that while for humans, dexterous manipulation of objects is a fundamental everyday task, it is still a challenging task for autonomous robots. In a blog post, the OpenAI team wrote that once fully trained, without dropping a cue, the neural network performed 50 successful consecutive rotations in a row. Contrary to a common belief, results show that RL algorithms can be applied to solve complex real-world robotics problems which are beyond the reach of existing non-learning-based approaches. For this, NVIDIA GPU and TensorFlow are used. Developers are hopeful their approach can solve more complex tasks in the future. Alex Ray, a machine learning engineer at OpenAI, said that they can go further beyond what hand-programmed robots can do. An AI can be trained with all kinds of combinations of scenarios, which translates to robustness when performing the task in the real world. In the future, developments in robotic manipulation will enable a new wave of robotics applications beyond traditional industrial uses. According to the D-Extreme project, simulation can be an amazingly effective tool for training complex robotic systems. By demonstrating the use of this relatively low-cost hardware, people can be inspired to use these simulation tools and build on this work as NVIDIA hardware and software are bringing deep learning to every device. That's all for today, and if you enjoyed this video, don't forget to share it with your friends Also, please check out other videos on our channel as well. Thanks for watching.